the same topic. So find the domain and sketch the graph. So we'll have the function f of x is equal with 5. So the domain here, I mean, it's all real numbers, because what does this here mean? It means that for every number you can put here, any number, the y it's always 5. I mean, this here is the constant function, and so that means that again, and also, you know, from what I said before, since there is no square root anywhere or a denominator like rational function, so that means that the domain is all real numbers. So R. And now if you want to sketch this, and that's pretty easy. So what we have that, what, you know, this is a constant function again, as I said earlier. So when you have that for any value x, the y is always the same. So let's say here is 5. So for this value here it's 5. For this value it's 5. For this value it's 5. So that means that the graph of function is this line here, which is parallel with the x-axis and pass through the point 5. Now, let's continue. Okay, so let's go to problem 33. Which is to find again the domain and sketch the graph f of x is equal with square root of x minus 5. So, I mean, again, this here is a square root, so you have to take only the values that they make whatever you have under the square root positive. So that means you have to take the values that they make this positive. So that means that you have to take all of the values for which x is greater than 5. So that means that the domain of this function is from 5 to positive infinity. And sorry, 5 is included, because here we have greater or equal. So that's the answer. Now, to graph this. So let's say, I mean, there are many ways of graphing functions, but for this particular one, because this here it's not a straight line. The graph of this is not a straight line. It's a curve. So that means that one way is to take a lot of points x and in the domain and find the y. So, but let's do this for now. I mean, so if you take, first of all, you have to take values greater or equal than 5. So let's say if you take for x equal with 5, you have that y is equal, if you put 5 here, 5 minus 5 is 0, square root of 0 is 0. So let's now take, let's take some numbers so we don't have to deal with decimals. So let's say if you take the number 6, say x is equal with 6, 6 minus 5 is 1, the square root of 1 is 1. Let's say then you take x equal with 9. So 9 minus 5 is 4, the square root of 4 is 2. And let's take one more. Let's say x is equal with 14. So you have 14 minus 5 is 9, so that means the square root of 9 is equal with 3. So if you want to graph this here, let's take the values in the x-axis. So this is the x-axis and this is the y-axis. So we'll go from 5, let's say 5 is here, all the way to 14. And in the y-axis you go from 0 to 3. So let's say this is 3. So I will have that for x5 you have 0. So this is the 1 point. The other point is for x is equal with 6, you have y is equal with 1. So let's say the other point should be approximately here. Then for x9, you have that y, let's say the 9 is approximately here. So you have that for x is equal with 9, you have that the y is equal with 2. So this is the other point. And finally for x is equal with 14, you have 3. So let's say the other point should be this here. So if you see, this is the graph, approximately. And for those you you study a little bit functions. I mean, this is half of the parabola. So and that's half because actually you have to take only the positive values, and of course it doesn't open in the y direction, it opens in the x direction. Now let's do the last problem. Yeah, this is problem 49. This is kind of more difficult problem. So what we have here, we have an open rectangular box with volume of 2 cubic meters. So the volume is equal with 2 cubic meters. Has a square base. So the base of this is square. And what we have to find, we have to express the surface area of this box. So surface area as a function of the side of the base. Okay, let me repeat. So we have an open rectangular box, and the volume of the box is 2 cubic meters, and the base of it's a square. We have to express the surface area of this box as a function of the side of the base. Let me do a small diagram to help you understand what's going on. So let's say approximately, so these here lines are broken. Yeah, so I mean, this is the box, and I mean, this is the base. I mean, we have two bases, and the top is open. it's a square, so that means that all these sides here are equal. So, and that's the length of let's say the height of the rectangular box. So what do we want to find? We want to find the surface area. We have to express the surface area as a function of s, and because we have here x, let's say that this is x. All the sides are of the top, of the base, the top and the bottom, of course, they are x. So we start from what is given. So what is given is the volume. So the volume of a rectangular box is given by the area of the base times its height. So of course you can use any as base, any side, any edge as base, and yeah. So here the base is this and this. So and the base it's the base is a square. So as we know, the area of the square is x squared. So times the height. So, and we know that this here is equal with 2. And we know it from here. So now let's go and find the surface area. So the surface area, we said this here is open, so let's say leave this out. So what it includes the base. So the area of a base plus what is around, which we call it lateral area. Okay, so by lateral area I mean all these four edges, this and this. So now the area of a base, because the base is square, the area of a base it's side square, so that means it's x squared. So and now the lateral area, we have 1, 2, 3, 4. So and all of them, they have the same area, because let's say we take this here, A, B, C, D. So this rectangle here, what's the area of it? Is the one side times the other. So it's x times this here. So because all of them are equal, we have 4 times. So it's plus 4. X, the side is x, and the height is h. So you see that everything is good, because you have here this is x squared, this is x, but the only thing which it's a bit bother us is the h, because we don't want anything else except x, because we want to find it as a function of x. So that means that you have somehow to take this out. And how we do this, from here, if you solve for h, because we know x squared times h is equal with 2, so if you solve for h, you have that h is equal with 2 over x squared. And now everything is good, because we can go back here and substitute the h with 2 over x squared. So now this cancels with this, and the answer is x squared plus 2 times 4 is 8 over x. So, and of course, this is the area of the rectangular box as a function of x, because it has only x on it.